All right, everybody, this is 9.4. Today we're talking about factoring quadratic trinomials with the greatest common factor. All right, everything else we've done so far, there wasn't a greatest common factor that we could take out at the beginning. So here in the steps, you can see that the first thing we should always check is for the greatest common factor. All of these problems are in standard form. That's ax squared plus bx plus c, where like this example, a is 2 and b is 10 and c is 12. So a, b, and c are always just like numbers, the coefficients. Okay. All right. So here we want to go through this process again. And again, the first thing it says is to factor out. Maybe I should have wrote factor out the greatest common factor. So if we look at these three terms, what's the greatest common factor? Well, it would be a 2, right? We could take out that 2, and then we'd need to write down what's left behind. So if we divide everything by 2, we would get x squared plus 5x plus 6. Okay? From there, we will do our glasses. Oops, kind of missed that. Okay? So we need to find the two things that multiply to give us 6x squared and add or subtract to give us 5x. So what would make that work? Well, we could write down factor pairs for 6, so 1 and 6 and 2 and 3. And it looks like we'd have to do 2 and 3, because 1 and 6, you could do 6 minus 1, but if we were to multiply those together, that would give us a negative 6, and it needs to be positive. So we'll need to do 2x and 3x, and then 2x plus 3x gives us 5x. Okay, so basically we have this greatest common factor, and then we have this x squared, and then we took this 5x and we're going to make that be 2x plus 3x, and then we have that plus 6. Okay, so this is where you kind of need to be careful. If you take out the greatest common factor, what we plug back in is what we have after, like what we use for our glasses. Okay, you don't revert to the original problem. All right, so now we could do our x squared and our 2x and our 3x and our 6, just like we normally did. But we have this 2 out here. What are we doing with that 2? Well, that 2 is going to go when we're all done. We're going to have this 2 out in the front. Okay, so now we'll do the greatest common factor for each row and column. So an x and a 3 and an x and a 2. So we'll have x plus 2 and x plus 3. And then, plus 3. And then we still have that greatest common factor that we took out. So that is the whole shebang. Again, there's a couple things that you got to be careful with. All right, and I'm going to give you another example of that and how I would maybe do it maybe a little different so that we can be a little more careful and not make mistakes. Okay, so this is where I just want to show you what would happen if you don't take out the greatest common factor. Okay, so if we took that, what was it? It was 2x squared, and I think it was plus 10x plus 12. And if you didn't take out the greatest common factor, I mean, you'll still be able to find the two things that make this work. So it needs to multiply. Here would be 24x squared, and needs to add or subtract to give us 10x. So you'd want to do factor pairs for 24, 1 and 24, or 2 and 12, 3 and 8, or 4 and 6. So first off, if you don't take out the greatest common factor, there's more factor pairs that you have to check. Up there were only 2, 1 and 6, and 2 and 3. But here we've got twice as many factor pairs that we have to check. All right, and now what would make that work would be the 4 and 6. So 4x times 6x gives us 24x squared, and 4x plus 6x gives us 10x. Okay, so now we would end up getting 4x squared plus 4x plus 6x plus 12. And then we'd use our box. So we'd do 2x squared, and 4x, and 6x, and 12. And we'd go the same sort of thing. Greatest common factor is 2x, and then 6, and then 2x, and then what, 4? Okay, so here if you were to multiply back, 2x times 2x, it does not give you 2x squared. It gives you 4x squared, so that didn't work. And 2x times 4, that should give you 8x, but here it says it's 4x. And 6 times 2 is 12, and this is 6. So looking at this, it's like, what in the world? This is not working at all. And the reason why is because we didn't take out the greatest common factor. So this is bad. Bad. Okay? You gotta take out, you have to factor out the greatest common factor. Okay? First, always. Okay, star, star, star. Please make sure you check that. On your homework and on your test, most likely it's going to be kind of a mixed bag. I'm not sure. Some of them there won't be a greatest common factor, but it's something you should always check. So important. What do you look for first when you factor? You always need to see if there's a greatest common factor. Okay? Again, that could be a number. It could be a variable. It could be a leading negative. Okay, so you still need to check for those every time. Okay, so for this one, this worked out great. X times x was x squared, 3 times x is 3x, 3 times 2 is 6, and x times 2 is 2x. So that worked out great. Just thing you got to make sure is that when you're all done, you got to still have that greatest common factor. All right, so let's do some other examples. Looks like we have a few here. So, step 1, greatest common factor. Is there one? Yes, there is. Okay, so we would want to factor out, looks like a 2. 2 would go into all of that. 4 goes into 8, but 4 doesn't go into 14. So we'd want to take out a 2, and then we'll divide everything by 2, and we'd get 2n squared minus 7n, and then minus 4. And then from here, this is where we're going to do our glasses. Okay, we can kind of ignore this from now on. It needs to multiply to give us negative 8n squared. So again, that just comes from multiplying our glasses. Okay, and then needs to add to the middle term, which gives us negative 7n. So maybe do factor pairs for 8. You can do 1 and 8 or 2 and 4. And it looks like the only thing that would make that work would be 1 and 8. So it'd be like negative 8n and plus 1n. That would give you negative 7. And then if you multiply, that does give us negative 8n squared. Okay? So from there, again, if you wanted to rewrite this, it'd be like 2, and then we have the 2n squared. The 7n is now the negative 8n plus 1n, and then we have that minus 4. Again, I've had lots of people, once they find these two things, they will revert to these to go in those boxes, but that's not, we can't do that anymore. This is what goes here, and this is what goes here. Okay? So we've got that. This is what I would also recommend, is that all your answers are going to be 2 parentheses. If you ever take out the greatest common factor, it's always going to be what's in the front. So maybe we should focus that, or like have that in our mind every single time, that we will have our answers with 2 parentheses, and then we'll say what's the greatest common factor, and we're just going to write it there so we don't forget. All right, so now we have these 4 terms, which means we can put them into these boxes. And then we'll do the greatest common factor for each row and column. So 2n, 1, n, and negative 4. Okay, so just again, we have to check all of it. If it's a number, variable, or a leading negative. So this has a leading negative. This does not have a leading negative. Okay. And then we also want to remember that we always have to take something out. So for here, the greatest common factor for the numbers would be 1. And since there's no variables or a leading negative or anything, we have to write down that 1. Okay? So those would be our answers that would go in here. So 2n plus 1 and n minus 4. Again, the order of those doesn't matter. If you did the n minus 4 first and then did 2n plus 1, okay? Okay, so here's just another example. This one's kind of important that we need to address this. So is there a greatest common factor? Okay, if you forget that the leading negative is part of the greatest common factor, then you're going to run into issues. You're going to make a mistake. Your signs won't work out. So here we have a leading negative. For the numbers, the greatest common factor would be 1. So we could factor out a negative 1. And in effect, when we divide everything by negative 1, it's just going to change all the signs. So we'll get 3x squared plus 11x minus 4. So we have that greatest common factor. We could write that here at the end so we don't forget. Okay? If you did forget that at the end, I mean, it won't be like a deal breaker for like when I grade your test, but if you want full points, make sure you get that. All right, so now we'll do the glasses. Negative 12 needs to multiply to negative 12, because I need more room for that. Negative 12 x squared, and needs to add or subtract to give us 11x. So our factor pairs for 12 would be 1 and 12, 2 and 6, or 3 and 4. Okay. And one needs to be positive, one needs to be negative. So looks like maybe that should be a 12. 1 and 12 would work. 12 would be positive, and then the 1 would be a negative, would give us 11, and then 12 times negative 1 does give us negative 12. So that would work. So again, we'll fill in all of our boxes. So this would be like 3x squared. This would be the negative 4. And then the 11x, again, is that 12x minus 1x. So greatest common factor, 3x and negative 1. Here would be x and 4. Okay, we can always check. Does that multiply correctly? Does that multiply correctly? Does that multiply correctly? Does that multiply correctly? Yes. So it looks like it all works out good. So again, those would be what goes in those parentheses. So 3x minus 1 and x plus 4. All right. Okay, so these are just some more examples. Again, what do you look for when you first, before you factor? We got to make sure we check out the greatest common factor. Okay. Let's go over this one. Is there a greatest common factor? Yeah, it looks like 3 goes into all of that. So we could factor out a 3. And we'd get x squared plus 6x plus 8. So we'll do our glasses with that. Again, if you take out that greatest common factor, you could put that 3 here, save that for later. Okay, so same thing here, we could factor out a negative 2. So we have a leading negative, and 2 goes into all of those. And then we'll write down what's left. So we'll divide everything by negative 2. So we'll get x squared, and then plus 1x, and then what, negative 20. And when we're done, we'll have this negative 2. We could do those parentheses. So I'm just doing those because that's kind of the new thing. Okay, so we're going to do all of those first. So greatest common factor for all those, there's not a leading negative, and we have this 2. So we'll divide everything by 2. And we'll get, well, is that the same as what's up there? No, it's not. Okay, so we'd get v squared plus 9v plus 20. And again, we could write down that 2 and those 2 parentheses. And then here's the last example. What's the greatest common factor? we have this leading negative, so we'll take out that -1, and then we'll divide everything by -1. So, and that would give us what? X squared plus 5x minus 36. And when we're all done, we should have this -1 in our answer. Okay? So now let's go and finish all of these. So just make sure you're checking, making sure if there's a greatest common factor, we take it out. Again, otherwise you're going to run into issues. But hopefully, again, like I said here, if you did the box and then check to make sure that when they multiply back, if it doesn't match, then we probably didn't get the greatest common factor. Okay? All right, so now we'll do the glasses. What multiplies and gives you 8x squared, and also adds or subtracts to give us 6x? Okay, so think about that for a second. For 8, you got 1 and 8, and 2 and 4. So we'd have to do something like 2x plus 4x, and 2x times 4x gives you 8x squared, so that's great. All right, so then we'll just take that in here, and that here, and then these go in these boxes. So we've got what? X squared, and then we've got 2x and 4x and 8. And we'll do our greatest common factor. So x and 4 and x and 2. And then those are your answers. So we got x plus 4 and x plus 2. All right, here's another example, glasses. We already know that this is going to be x squared and this will be -20. We just need to figure out what we need to break that into. So it needs to multiply to -20 and adds or subtracts to give us 1. So my guess is those numbers are really close. One's going to be positive, one will be negative, like 4 and 5. So 4 and 5 would work. Maybe 5x minus 4x. So we could do 5x and -4x. And then, again, that multiplies, that 5x times -4x does give us that -20. So greatest common factor would be x and -4 and x and 5. And again, you can check and make sure that works out. So, oops, x minus 4 and x plus 5. Again, the order of those parentheses doesn't matter. If you did the x plus 5 and then the x minus 4, that's just fine. All right, last two. Glasses. So again, multiplies to 20, v squared this time, and needs to add or subtract to give us 9v. So for 20, you got, what do we got? 1 and 20, 2 and 10, 4 and 5. So 4 and 5 would work. So 4v plus 5v would make that work. So again, we have this v squared, and we got that 20, and then we got the 4v and the 5v. Greatest common factor, v, 5, v, 4. So v plus 5 and v plus 4. Got it. And then the last one, glasses, multiplies to -36 x squared and adds to 5x. This one's a little bigger numbers. Let's see if we can figure it out. So it has to multiply to 36. So factor pairs would be 1 and 36, 2 and 18, 3 and 12, 4 and 9, and 6 and 6. So those are the factor pairs. And which of those would give us a 5? So one's going to be positive, one's going to be negative. So if you did 12 minus 3, that gives you 9. 9 minus 4 would give us 5, so that would work. So we could do something like 4x minus 5, no, sorry, I did that wrong. 9x minus 5x. Okay, so we got this x squared, and we got that negative 36 already, and then we're taking those two things, so 9x and negative 5x. So greatest common factor, x, negative, oh sorry, I think that should be oh yeah, it's supposed to be a 4. Sorry about that, so that should be 4. So greatest common factor here would be negative 4, and greatest common factor here would be x, and what, 9? And we can check, x times x is x squared, negative 4x, 36, negative 36, and 9x. So that looks like that all works out. So we've got x minus 4 and x plus 9. All right, so I know there's probably going to be lots of questions as you go along. Do your best. Come and talk to me if you have questions. I know this is as big as it gets, okay? Greatest common factor, and then we do glasses, and then we use the box and find all that stuff. So it's a lot of stuff, but do your best. Take notes as you went along. Hopefully, pause and practice. Check your odd answers on the back, and come and get help if you need to. All right, we'll see you guys.